In a groundbreaking announcement that could change our position on Earth, NASA has announced the discovery of the first signs of extraterrestrial space. The signals come from Proxima B, the closest planet to Earth. More than 4 light-years away, Proxima B is in the habitable zone of the star Proxima Centauri. This discovery caused worldwide excitement and interest. Is this when a man realizes that he is not alone in the world? The journey to this great discovery began with NASA's powerful telescopes. They have been scanning distant stars and planets for signs of life, and Proxima B is a prime candidate. The observed sign is different, unlike anything astronomers have seen before, and marks a turning point in human history. The conditions are great. First, it confirms the long-held hypothesis that the planets exist under Earth-like conditions. Second, and better, the question arises, what kind of people will live there? Are there microbes or advanced organisms capable of interstellar communication? This signal from Proxima B is not just random noise. It is a structural repetition that indicates a conscious origin. NASA scientists, along with international teams, are now working to decipher the message and understand its meaning. The international scientific community is full of theories about the content of the message. Is this a compliment, a warning, or what? The discovery sparked controversy outside the scientific community, sparking discussions on social media, in government circles, and at dinner tables around the world. People also look at the stars in awe and imagine people doing the same in a distant world. How are their worlds similar or different? How does your community feel about technology and culture? There are only so many possibilities in the world. In addition, this analysis opens up several ethical questions and concerns. If these signs come from intelligent people trying to communicate, how will people respond? What is the protocol for interstellar mediation? And more importantly, how does such a discovery change our understanding of religion, life, and our identity as human beings? As excitement grows, so does exhaustion. Scientists at NASA and other space agencies are working hard to confirm these findings and ensure that the positive signal is not false or misleading. We are on the verge of discovering the greatest thing in human history, so we must take the next steps carefully. The world is waiting for further analysis. Seeing alien signals from Proxima B not only brings our science into a new era, but also brings together curiosity and hope. We may finally be close to answering one of the oldest and most profound questions. Are we alone in the world? In April 2019, a radio signal was detected from space, specifically from the region of Proxima Centauri, 4.37 light-years away. Although the distance seems great, it is the closest star to the Sun, 3 times the distance of the third brightest star in our sky. The symbol originates from a triple star system consisting of the binary pair Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, 2 companion stars, are close to each other and are about the same size as the Sun. Alpha Centauri A is bright yellow and 1.5 times brighter than the Sun, while Alpha Centauri B is brighter orange. Alpha Centauri A is smaller than our Sun and Alpha Centauri B is smaller. But where is the sign between these 2 stars? The Breakthrough Listen program, which is dedicated to the search for extraterrestrial communications, named this Signal Breakthrough Listen Candidate 1, or BLC-1. The project, which has a budget of about $100 million, has used thousands of hours of observation and the eyes of international artists around the world. This signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope observed the region of Proxima Centauri, the nearest star to our Sun. The signal was not found among the amount of data collected in thousands of hours, but the researchers were able to see it like a needle in a haystack. In order to be considered a valid indicator, 2 specific conditions must be met. First, it must be limited to a low frequency range, because these radio signals are not generated by natural machines in space. Second, the frequency should change based on the exoplanet's relative motion to Earth. About 4 million points were captured by a telescope in Australia by scientists. After a long process of analysis and removal of irrelevant signals, they found 5,000 unique signals, one of which could not be explained. After reinterpreting with new ground-based radio transmitters, this unique signal and signature of the narrowband technology appeared for the first time when the telescope was aimed at Proxima Centauri and observed within 30 hours. After careful analysis, it was found that the planet came from Proxima B, a planet discovered by astronomers in 2016 using the method of radial velocity, which determines the position of the star due to its gravitational pull. The current distribution is recorded. The star represents a small circle. Scientists use highly sensitive telescopes to track the star's light. The light intensity of stars shifts slightly towards the blue side when they approach the planet, and towards the red side when they move away from the planet. These movements occur at regular intervals throughout the day, month, or year, and can be thought of as the lunar cycle caused by the gravitational pull of the rotating planet. A closer look shows that Proxima B is very similar to Earth, with a radius of 1.1 times that of Earth and a mass of 1.3 times that of Earth. However, there are significant differences. The first is the location of the two planets in their respective solar systems. Proxima B is closer to its host star by just 5 cents, while Mercury is 39 cents from the Sun. This proximity makes Proxima B the hottest planet, but because Proxima Centauri is a faint red dwarf, it receives 60% of the energy that Earth receives from the Sun and puts it inside in a place to live. There are many unknown planets scattered throughout our universe. We have discovered 4,935 exoplanets so far, and have added 65 new ones, bringing this new group of 65 exoplanets to 5,000. An important symbol of planetary exploration. The James Webb Space Telescope, or JWST, is the most advanced telescope ever built and is 100 times more powerful than its predecessor. With his help, we can unlock the secrets of the universe. In the past, we have discovered a wide range of planets, from small rocky worlds to gas planets larger than Jupiter, to the hottest and habitable planets. Among these observations, a few planets stand out. Kepler 186f is one of the planets with similar characteristics to Earth. In fact, it is the most beautiful planet we have ever seen that can support life. We've discovered 55 Earth-like planets so far, but we haven't been able to study them all. With the rapid development of our technology, especially with the James Webb Telescope, who knows what else will emerge? Wouldn't it be wonderful to discover a planet that could support life? One of the main goals of the James Webb Space Telescope in its first year of scientific operation is to find and study exoplanets outside our solar system, focusing on the nature of structure and form in water and organic matter. Alive Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as link our own solar system to their origins. Webb's infrared capabilities are ideal for revealing how stars and planets form. For 3 key reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components, such as water and organic compounds. Mid-infrared light can pass through clouds 20 times denser than visible light, which is especially important when observing newborn stars hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation, when gas and dust are still contracting to give birth to young stars. But family clouds are much more than this. Young stars and giant planets start out as large, inflated structures that shrink over time. As newborn stars burn up over the years, the giant planets cool, but both are brighter in the infrared spectrum than in visible wavelengths. This means that the telescope will be useful for finding new stars and planets and helping to understand the physics of their formation. The MIRI instrument is also looking for hot molecular gas near young stars, which may indicate the formation of habitable rocky planets. Not surprisingly, much of the early science work of the James Webb Space Telescope has focused on determining how the large molecules formed at the origin of life.